Hello again, everyone. Our next session is with Andy Mcmahon, and the topic is insight-driven decision marketing at Aggreko. Aggreko is the world leading provider of power, temperature control, and energy services to customers across the world. This talk will detail how they use a modern cloud-enabled tech stack and advanced machine learning capabilities to deliver value from analytics solutions consistently and robustly through their colleagues and customers. Andy Mcmahon is the leader of the advanced analytics team at Aggreko, which specializes in creating robust machine learning solutions across different verticals for the global business. He won the Data Scientist of the Year award at this category in 2019 International Data Science Awards, and he's spoken at several conferences on how to create successful data science projects and products. As with the previous lectures, you can post your questions, and then at the end of the Q&A session, Andy will come by and answer some of them. So enjoy the lecture.
Hi everyone, I'm Andy Mcmahon. I'm the analytics team lead at Aggreko, and I'm really glad to welcome you to my talk today on insight-driven decision making. I'm really glad to be here at the Data Science Conference. Today I'm going to take you through a few different topics of relevance to the work we do at Aggreko. I'll start off with a little bit of background on who we are, what we do, and how we work to support our customers across the world. I'll then move on to discuss how we work with data in the business, in particular focusing in on the wider team that I'm part of, our insights team, and how we extend that further into what we call the extended data team across the business. I'll then focus in on specifically the data science, advanced analytics, machine learning capabilities and focus at Aggreko. I'll then elaborate on that a bit with a discussion of our technology and our development strategies. And then I'll finish off with a case study to try and crystallize everything I've been talking about. So up on the page just now, I've got what's called our insight strategy. And this is essentially the guiding star, if you like, for everything we do with data in the company. And everything my team does and the wider data team, we do to support this strategy. So we're trying to deliver insight-driven decision-making across the business. We're trying to innovate constantly. We're trying to produce interactive and visual insights that are easy to understand. And we want to provide the right information for the right people at the right time in order for them to make the correct decisions for the company and for our customers. But before I go into a lot of depth about what we do and how we support this strategy, we first have to say what Aggreko are. Who are we? So Aggreko are the world-leading provider of mobile modular power, temperature control, and energy services. So what we provide could be anything from energy support for unique commercial industrial projects through to utility scale energy provision, and even supporting countries going through humanitarian emergencies. An example of this was earlier in the year when Aggreko actually offered the British government up to 1,300 generators free of charge in order to help setting up COVID testing sites across the UK. So our company's overall mission, which you can see up on the screen here, is really quite a positive one, and there's a particular focus on making a very positive impact on the world through our solutions and our services. So that makes it a really exciting place to work and do data science. And I'll hopefully share some of that excitement with you through my talk. And the impact I was mentioning is really on a global scale. So we operate across 100 countries, 265 locations through our 7,000 employees. And we have just over 10 gigawatts of power in our distributed on hire rental fleet. And that's just the power element. We also supply, as I mentioned, temperature control and other energy services, so dehumidifiers, compressors, etc. And in 2019, we were so successful at delivering these services and products that we took 1.6 billion pounds in revenue. So you can see from this that if we are able to make an impact through data, it really will have global reach and a very wide-reaching impact, which again makes it another exciting reason to work here at Aggreko. But now I want to go into a bit of detail about how data sits within the company and how we can see Aggreko Insights as part of a wider picture. So Aggreko Insights really forms the core of what we call our extended data team. So our extended data team usually consists of multiple parts. So in a particular project, we may have people working from the advanced analytics team, which I lead, where we're dedicated to understanding our data at a really deep level with a focus on analysis, algorithms, decision science. We then work alongside our business intelligence colleagues, whose key aim is to provide operational reporting to the business, making sure that the insight we're delivering gets to the right people at the right time in that interactive and visual way. And we're both supported really strongly by our data engineering function, which is tasked with the ingestion, transformation, and curation of all of the data from across the business into our enterprise data lake. And then finally, in any project, potentially the most important set of team members is actually from our internal partners at Aggreko. So Aggreko has really world-leading expertise across a variety of different domains, especially in the engineering sector that we operate in. So we always make sure that we leverage that expertise in any given project. And we always work with internal stakeholders to make sure that what we're working on is really tied quite directly to strategic business objectives. And that ensures that we're delivering products that will generate value, but also will actually have uptake and be used. And this approach has been really successful for us. So some numbers to put into context, the scale of that success are, if I focus on kind of the advanced analytics projects we've worked on, we're most heavily collaborating with data engineering and our internal partners. Over the past year alone, we've analysed terabytes of data. We've delivered more than 10 machine learning algorithms to production running on daily cycles. And that's led to millions of dollars of insight, which we can directly attribute to these machine learning algorithms running in production. So this extended data team is not just a good idea, it's paying dividends for the business and for our customers. But that's the wider case. What if we dive into a bit more detail on the advanced analytics, the data science side? So at Aggreko, we have, as I mentioned, that global business that has to solve a variety of different challenges and problems for our customers. And these span a few different verticals, if you like. So the first and kind of core area that we work on for data science at Aggreko is really around the assets that we have. How do we maximize the performance? How do we improve the servicing of those assets? How do we optimize the inventory associated with those assets? The next layer surrounding that really is around how we use those assets and deploy them. So how do we manage our fleets? How do we increase the utilization of each asset to make sure that we get the best use of the products we have? How do we appropriately finance the operations that we have? And then how do we judiciously procure the right support for our operations? And then finally, there's sales and marketing, where the data science team work to understand how markets segment, how our customers can be priced appropriately, how we can go after the right opportunities, and how we can make suggestions for our customers that can improve their experience and mean that they have stronger partnerships with Aggreko. So from that, there's just so many questions that come out, and we always work with our internal partners to triage and prioritize these so that we're going after the right things and creating that value. So that's how data science at Aggreko roughly works at a 10,000 feet view, if you like. The next question I want to answer for you that you might be asking is, how do you do this at a technical level? This is quite a technical conference, so I'm sure a few of you will be interested in the tools and technologies we use. And the key overarching thing to mention here is what we call our modern data platform. So this is a collection of tools and technologies all built together into a scalable and robust architecture, all of it cloud-based, where we can really sustainably ingest data from a variety of different sources across the business into our enterprise data lake, which actually leverages the tools and technologies of Delta Lake, so that we have bronze, silver, and gold layers, which are different levels of transformation applied to the raw data. We then use Azure Databricks mainly as our heavy-duty compute engine, and that feeds into a variety of different further pipelines, that these data transformation and data surfacing processes, where we could be leveraging Power BI for visual insights, mainly through the BI team. Our applications development team could be developing software using the data that we surface into different databases. Or in my team, we could be developing real-time, consistent analytics models. So we could be creating machine learning algorithms running on schedules or running in streaming. And we do that again through leveraging Databricks and tools like MLflow for model versioning. So that's, in a nutshell, our modern data platform, and that really underpins the success of data science at Aggreko, and more widely, insights at Aggreko. And we've went through a long journey of building that data platform. We're still working on some elements of it, but it's really been this underpinning technology and the integration of all the different teams and pieces that's driven our success. Here I've given a bit more of a detailed view of all of the components involved in that platform, because if anybody in this audience is going to go and try and do the same thing, you'll come across many of the challenges we have and understand this is a very complex thing to do. But what's been really important for us to make sure that we keep driving forward and creating that success both internally and for our customers is that we divide this data platform into areas of responsibility, like I've shown here. So data engineering within that wider extended data team I mentioned before, really focus on the ingestion, transformation, curation of the data. The BI team, the provisioning of the semantic data models and visual insights for consumption by people in the business. And then we really focus in advanced analytics on machine learning models, predictive analytics, descriptive statistics, and other modeling techniques in order to ensure that we are supporting the business to make the right decisions. But having the domain in which we work and having the way we work within the wider team is only part of the story. Once you have the problem and the tools and the team, you then need to have a process for actually developing your solutions. And that's one of the areas I think we've been really innovative, especially over the past year. And that's through our data science development process that we've worked on, and I'll share with you now. So the key element to data science dev really for us is that the elements of software development and software engineering that work should be completely integrated with your data science team, your data science development processes. So we don't have an isolated data science team that develops a proof of concept and then hands over to software engineering. We don't do that. We basically take the approach that we own our solutions from ideation through to production, and then in production as well, up to a certain level. We may have people from operations within IT to help us once we get to that stage, but really we own these services that we build. And to make sure that we build them in a robust way, we as I mentioned, borrow a lot of the elements of software engineering, software development. So we will use IDEs to develop our code. We'll do test-driven development. We'll really think hard about designing our products to leverage object-oriented or functional programming techniques. We'll really work to develop robustness and consistency through a variety of different tests, not just unit tests, but integration tests, regression tests. That becomes part of the process. And then we make sure all that is under version control and that it's managed in a DevOps process. So we use actually the Azure DevOps tool, since we're mainly based in Azure, so that we have things like our Git strategies for pull requests, merging of code. We have automated builds. We're working on CI/CD pipelines. We work in an agile fashion, so we leverage the idea of sprints. And then we make sure that we have all of our documentation consistent and up to date, as if we're building packages, which in fact we do. We build packages for us to use and reuse again and again. So our data science code doesn't just sit somewhere as a script that you occasionally run. It becomes part of real software that actually is run and used robustly. And then finally, we still have to have another element here, which is an environment in which we can experiment. We can develop tools that will work with really large data sets. And as well, we need a computing environment in which we can execute our software packages. So we leverage Databricks for that, which is basically a platform that sits on top of Apache Spark, but manages a lot of the infrastructure under that, so that you don't need to think about it, which is really helpful for us. So within that, you get the whole notebook experience we're used to from data science. You can experiment, you can collaborate together and work jointly in your notebooks. You can be flexible with languages. We work mainly in Python and PySpark, but you can switch to Scala or R. You naturally have distributed execution out of the box because, as I say, that's managing that Spark infrastructure for you. And it really plays very nicely with other tools like Delta Lake and MLflow. And so what we do basically is we allow these three parts to execute together so that we can execute our code robustly, we can orchestrate what we're doing and how we're building it, and we can really work to engineer things appropriately. And the way that comes together is using basically an architecture like this, if you like. This is a very rough, high-level view. For more details on this and how it works, I'd really recommend going to one of the other talks from other members of my team, the High Throughput ML Development for Condition-Based Maintenance by Helena Orejuela, Salvatierra, and Lindsay McCurdy. So they'll be able to tell you a bit more depth about this, but in a nutshell, we have our storage layer at the bottom, which is our Delta Lake, as I mentioned before. On top of that, we have those libraries that we build. So we build our packages mainly through building Python libraries to make sure we reuse our data science and machine learning code. We'll be able to install and use them on Databricks clusters in order to chain things together to build data acquisition and modeling pipelines. And then finally, we have an orchestration and messaging interface layer, which really works based heavily on Azure's surrounding tooling. So things like Azure Logic Apps, Azure Cloud Functions, and things like that. But also with a bit of Databricks in there to orchestrate the notebooks and the jobs that we're running on the Spark clusters. And the layering up of this functionality really, as a package, now means that we have the process, the way of developing these tools in order to deliver solutions that are quite robust, scalable, and run on very repeatable cycles. But that's not the full story. Basically, that architecture can be split into two basic flavors of deployment. So the one on the left here is what we call scheduled batches. So this is our kind of standard deployment route just now, where we take data from a certain solution. Here I'm showing it from the system that gathers data for assets, take it into the lake, data lake. We feed it into Databricks to run our ML models, and then we send out the outputs through that messaging and orchestration interface to various different solutions. But now we're also experimenting with the idea of this being something a bit more dynamic and working to build ML as a service microservices. So really having self-contained systems which can be dynamically triggered through a request in order to perform inference. And this, we found a few use cases for this. I'm actually going to speak about a case study where we've experimented with this later. That's really good at taking a more dynamic approach and ensuring that things are coming in on demand. So just to sort of take a break there in terms of the high level view and then move down to a really detailed case study. What I want to talk about now is the use case for advanced analytics at Aggreko, which has shown a great deal of value over the past few years, and that is the development of our predictive alarms and condition-based maintenance programs. So the main idea here is that we work in this batch process I mentioned before, and we also have a variant that works in the microservice architecture that I mentioned. But really what we're doing is we're taking data from the assets, really our telemetry signals, pressure, voltage, temperature, all of these things, take them into the lake, have them provisioned and curated in line with the data engineering team. That then goes into our production environment where the Databricks models can then run and isolate anomalies in these signals. And we can then raise alerts and summarize and aggregate the results of this modeling. And then what we do is we take that through to one of several different output channels. And some of them are shown here. So sometimes we'll send an email to relevant people in the business. Could be an email alert saying there's an anomaly you should investigate. We'll often show and render things in Power BI. We'll work in partnership with our BI team and that extended data team I mentioned earlier in order to provide interactive and visual insight. But one of the most important areas that we output to for predictive alarms is really the alarm management system, or AMS, at Aggreko. So this is an interactive web application that was built by the internal applications development team here. And this provides a pane of glass through which we can surface these alerts to technicians in the business. And you can see a kind of screenshot here. It basically shows a table. In that table is information about any alarms that have been raised, provides high-level customer information, information about the application that the generator or generators are on. We assign a priority into that table to help with triage and prioritization of activity that will be triggered based on these alarms. So this could be critical, major, or minor. And then finally, there's contextual information in this view in the application, giving you things like satellite views of the site, notes on the asset, contact information for customers or for our technicians on the site. There's a variety of other tools and techniques under the hood within this application, but this is the main page that we sort of surface our results into. And that's been really successful and been part of that millions of dollars of insight that we've driven. And one particular use case that I want to touch on of doing this is in our fuel services division. So when Aggreko work with a customer, we can often agree that we will manage their fuel requirements for their power generation. So we'll hire out the generators, but we'll also hire out fuel tanks, and we'll basically say we'll take over the refueling of those tanks. And one of the ways we do that to try and be a bit more proactive is using our remote monitoring software, so ARM. So this is a system that allows us to have sensors inside the tank telling us what fuel levels we're at and how that's changing with time. And that gives us really 24/7 visibility of those tank levels. And this is the same software, same hardware that's used to give us all the other telemetry signals from our generators, but now we can apply it to fuel tanks. But very quickly, you find that you will run into a bottleneck, a bit of a challenge, as this scales across that global footprint that I mentioned Aggreko has. So if you're managing thousands and thousands of these tanks across tens of thousands of sites or thousands of sites, you can't do that with basically a series of humans in a room trying to monitor these signals. You just very quickly reach the limit of that approach. And that's because it's complicated. So what ends up happening is our customers can experience fuel outages. We can have parts on the site where we consume the fuel and the tank is empty, and we have to then basically charter a truck to go out with fuel very quickly. And doing that in a non-optimal way will lead to high logistics spend as well. So it impacts the customers, but also impacts obviously Aggreko as well. So to tackle this challenge, we worked as part of an extended data team. We brought together technicians and fuel experts from across the business, working with members of my team. And what we did was we really got to the root of the problem, which was we need automated forward visibility of the consumption rates of the fuel in these tanks. And then we need an automated alert if it looks like we're going to run out of the fuel within some specified time frame, which we discovered through the course of the project. So what the team worked on to develop was something that followed the kind of typical archetype for our deployed predictive alarms. And that was where we have a data ingestion process that works at the asset level. Here it's based on a couple of months of historic data. We pull in configuration information for the tank, any surrounding equipment, the agreement it's on with the customer, and obviously the fuel levels through history. That will then be fed into our feature engineering pipeline, where we perform data analysis, data cleaning. We'll extract and transform the signals in an appropriate way for our machine learning models to understand. And then we developed a model. So we actually created a bespoke forecasting model using a variety of different techniques from scikit-learn, from Spark ML and we leverage as well Pandas UDFs, Python UDFs in Databricks and Apache Spark in order to leverage the distributed nature of the platform we're using. And what we showed was that you can do this very robustly across all of the tanks that have this ARM software installed. So if we have the data coming in for it, we now deploy this system to monitor the levels, constantly run forecasts on a schedule, and then alert an alarm if it looks like we're going to run out of fuel within some set time period. That will then send that alarm to that alarm management system I mentioned earlier. A technician or a field desk manager will see that and then be able to take proactive action in order to refuel, stop fuel outages, and reduce costs for us and our customers. So it's been a very successful piece of work, and it's currently deployed and running live right now. Well, that's just one use case, and hopefully it's given you a flavour of what we do, delivering insights through data science, machine learning at Aggreko. So in conclusion, really, just to summarise everything I've discussed, at Aggreko, I've hopefully shown you that data-driven insight is just embedded into our operational business. It's just part of our DNA now. Collaboration is at the heart of that strategy and really critical to that being a success. It wouldn't work if we didn't work in that extended team with other members of the business. And we always work to support established processes and objectives, and I've hopefully shown how that ensures uptake, feedback, and value from our solutions. Our global presence is something I've laboured on quite a bit about here, but it provides an interesting challenge, and hopefully you've seen how that presence and our 24/7 ops means we really have to provide our insight in multiple ways and quite dynamically as issues arise. And I've shown how our platform and tool choices were really selected and designed with that flexibility in mind. And then finally, I've spoken about how our advanced analytics team works with other members of the business to create solutions that are already creating millions of dollars of value annually, which is a real success story for data science at Aggreko. And the specific use case I went through about prediction-driven alarms for our assets and our fuel services is just one example of how those insights are improving efficiency and customer service levels ultimately. So with that, I'm going to finish, and thank you very much for listening.